Today's unit is going to be about discussing slope. When we think about the word slope, we oftentimes consider things like hills, mountains, and ramps. Now, why is it that we oftentimes consider hills, mountains, and ramps when we think of the word slope? It's because whenever we look at these hills, mountains, and ramps, we're seeing a change in the vertical distance and a change in horizontal distance. In other words, what we're seeing is a change in the height and a change in the length, which we're going to represent as y and x for our purposes. Let's consider two ramps. When we look at these ramps, I want you to consider which one is steeper than the other. So go ahead, take a few seconds. If you need to pause the video, go ahead and do so. And tell me which of these two ramps is the steeper ramp. Now we can agree that this ramp is going to be steeper than the adjacent ramp. Why is it that we say that this ramp is steeper? It's going to be because this ramp has a greater vertical change at y compared to its horizontal change than this ramp does. In other words, the steeper the ramp, the larger the change in y compared to the change in x is. Mathematically, whenever we want to look at the slope of a line or the steepness of a line, we want to look at it on what's called a Cartesian plane. And the Cartesian plane is named after the French mathematician René Descartes. So, on our Cartesian plane, our horizontal axis is going to be called our x-axis, whereas our vertical axis is going to be called our y-axis. So let's draw one of our ramps on this plane. Now, looking at this line, the slope of this line is going to be whatever this vertical distance is. So the vertical distance it's traveled is whatever the y-coordinate is, compared to whatever the horizontal distance is, which is the x-axis. And mathematically we can symbolize that as the change in y over the change in x, or as delta y over delta x, where delta just means change in. Numerically, this can be represented as the slope, which we're going to use the letter m to symbolize, is equal to the difference in the y's. So we're going to say y2 minus y1 divided by the difference in the x's, or x2 minus x1. Let's say we have a line that has endpoints at the origin, which is 0, 0, and at, we'll say, 4, 4. So the slope of the line connecting these points is going to be found by using our formula m equal y2 minus y1 over x2 minus x1. So in order to find the slope of this line, I'm going to look at my two coordinates. So I'm going to rewrite them here as 0, 0 and 4, 4. Now, to figure out what the slope of this line is, I'm going to substitute my y2. Remember, y is my second coordinate, so it's going to be 4 into my equation minus y1, which is going to be my y coordinate at my first point, which is 0, over x2, which in this case is 4, minus x1, which is 0. 4 minus 0 is going to give us 4, divided by 4 minus 0 is 4, and 4 over 4 is going to simplify as 1. So we say that the slope of the line connecting these 2 points is 1. Now, remember that the slope is another word for steepness. So the steeper a point is, the higher the slope is going to be. So what I have here is the 2 points 0, 0 and 2 comma 8. And I'm going to try to draw a straight line connecting them. So as we can see, this line is going to be fairly steep. And in order to figure out what the slope of that line is, we're going to again use our formula, m equal y2 minus y1 over x2 minus x1. And in this case, we're going to use m equal 8, because again, my y coordinate up here is 8, minus my other y coordinate is 0, divided by my x coordinate here is 2, and my x coordinate here is 0. So 8 minus 0 is going to give us 0, and 2 minus 0 is going to give us 2. 8 over 2 is going to simplify to be 4. So the slope of this line is going to be m equal 4, which is a little bit steeper than our previous line, m equal 1. Thus far, all of our points have examined one endpoint being located at the origin. So let's take a look at a set of points where our endpoints are not located at the origin. So let's have -1, 4, and 3, 7. Now, if we were to graph these points, we're going to see -1, 4 located here, and 3, 7, 5, 6, 7 is going to be located here, and the line between them. Alright, so the slope of this line is going to be found using the same formula, m equal y2 minus y1 over x2 minus x1. And we're going to start using our y2, which is this point, 7, minus our y1, 4, over x2 is 3, minus our x1 is -1. Remember that whenever we subtract a negative number, it becomes a positive number. So our denominator is going to become 3 plus a positive 1. 7 minus 4 is going to give us 3, and 3 plus 1 is going to give us 4. So the slope of this line is going to be m equal 3/4, or you can write it as m equal 0.75. Let's try one slope equation on our own. So I want you to calculate the slope of the line containing the points 2, 5, and 4, 8. Now, feel free to pause the video if you need to. I'm going to give you about 10 seconds to figure out what the slope is between these 2 points. Alright, so our answer should be m equal 3/2 or m equal 1.5. So the way that we got this was by using m equal our y2, which is 8, minus our y1 is 5, divided by our x2, which is 4, minus our x1, which is 2. 8 minus 5 is going to give us 3, and 4 minus 2 is going to give us 2. So the slope of the line containing these 2 points is going to be 3/2 or 1.5. If we look back at our mountain example, then we can see that as we start from our base and we climb the mountain, we're going to increase our vertical distance and our horizontal distance. And so if we increase both of these, we're going to have a positive slope. So if we start out here at base camp and then travel up our mountain, then our slope is going to be positive. But what if we start at the top of our mountain instead? What if we start up here at the top and then we need to travel back down to the base? In this case, notice that the slope is going downward, so this is actually going to be a negative slope. So if we look at our graph from left to right, if it increases, as we can see in our first example, then we have a positive slope. If when we look at our slope going from left to right, it goes downward, we're going to have a negative slope. And this is going to be determined by the sign of your slope. Let's look at some points that have, in this case, a negative slope. So I've gone ahead and labeled the 2 points 0, 4 and 4, 0. So as we can see from our line, the slope is decreasing as we go from left to right, meaning that we have a negative slope. So whenever we calculate our slope using our formula, it should be negative. So let's go ahead and look at that. So we're going to have m equal our y2. In this case, our y2 is going to be 0 minus our y1, which is 4, over our x2, which is 4, minus our x1, which is 0. 0 minus 4 is going to give us a negative 4, and 4 minus 0 is going to give us a positive 4. Negative 4 over 4 is going to give us negative 1, so we see that this line has a slope of negative 1. So I've gone ahead and drawn two lines here, so I want you to take a few seconds and determine which of these lines has a positive slope and which of these lines has a negative slope. Feel free to pause the video if you need more time. So we should have gotten that this line on the left, as it goes from left to right, it is increasing. So it means that it has a positive slope. And our line on the right, as it goes from left to right, is decreasing. So this is actually going to have a negative slope. So remember that if it increases from left to right, it is positive. And if it decreases from left to right, then it is negative.